for number 27, we want to show that the triangle with these vertices is isosceles. So what we got to do is we got to find the distance between all of these points and see that two of those sides are equal for this to be isosceles. So let's start with AM. AM is equal to the square root. Well, this formula is x2 minus x1 squared plus y2 minus y1 squared. That's Pythagorean's theorem. X2 is the x value of the second point. This is the x value of the first point. So 3 minus a negative 3 squared plus y2 is 1 minus 4. And this is going to be 3 plus 3, which is 6 squared, plus this is going to be a negative 3 squared, which will be the square root of 36 plus 9, which is the square root of 45. So AM is, this is 9 times 5, and this comes out as a 3. So this is 3 root 5. Now let's find the distance between A and Y. So AY is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared, which is, we'll call this point 2. So x2 is 0 minus negative 3. Oops, what did I just do? 0 minus a negative 3 squared, oops, like that, plus the y's, negative 2 minus 4, which is 0 plus 3, which is 3 squared, plus negative 6 squared. This is going to be the square root of 9 plus 36, which is the square root of 45, 9 times 5, and this is 3 root 5. So we can see that this is isosceles, or it might be equilateral. We'll find the distance between the last two. So the last 2 points are MY. So the distance between M and Y, I don't know if I should write this formula again, but I will. Okay, so we'll call this point 2. So this is going to be 0 minus 3. And then, oops, what did I just do? Y2 is going to be negative 2, and we're subtracting 1. And this is going to be the square root of negative 3 squared plus negative 3 squared, which is the square root of 9 plus 9. Oops, what did I just do? Which is the square root of 18, which is the square root of 9 times 2, which is 3 root 2. So these are the 3 sides. We have, this is the distance between 2 of the points, this is the distance between 2 of the points, and this is the distance between 2 of the points. Because 2 of those distances are equal, this is an isosceles triangle. This is an isosceles triangle. Number 42 says to discover and prove 2 things about the triangle with these vertices. So first, why don't we find the distance between each of those points? So KM is equal to the square root. This is Pythagorean's theorem. I'm not going to write the formula in, but this is x2, which is the x value of the second point, 3 minus x1, which is the x value of the first point, plus y2, which is the y value of the second point, minus y1, which is the y value of the first point, which is 3 plus 3, or 6 squared, plus This is negative 3 squared, which is the square root of 36 plus 9, which is the square root of 45, which is the square root of 9 times 5. And we take this out by square rooting it, we get a 3. So this is 3 root 5. Okay, let's do the next two. We'll find the distance between k and j. The square root of x2, which is the x value of the second point, that's negative 6, minus x1, which is the x value of the first point, that's a negative 3, squared, plus y2, which is the y value of the second point, minus y1, which is the y value of the first point. This is negative 6 plus 3, which is a negative 3. And this becomes a negative 6. So this is 9 plus 36. We just did this, so I'm not going to do this again. We know that this is going to come out to 3 root 5. Finally, we'll find the distance between the last 2 points, which is mj. So we have the x2, which is negative 6, minus x1, which is 3, squared, plus y2, which is the y value of the second point, negative 2, minus y1, which is 1, squared. This is the square root of negative 9 squared plus negative 3 squared, which is 81 plus 9, or the square root of 90. Let's see. This is the square root of 9 times 10. And we take out the 9 by square rooting it, we get a 3. So this turns into 3 root 10. Okay, now we can see that this is an isosceles triangle because 2 of the sides are equal. So one thing we know is that this is isosceles. Okay, now I think we can find that this is a right triangle as well, because here, this is, if this were a right triangle, this would have to be the hypotenuse, because 3 root 10 is clearly larger than 3 root 5. So in a right triangle, a squared plus b squared equals c squared. So 3 root 5 squared plus 3 root 5 squared, is this equal to 3 root 10 squared? Well, 9 times 5 is 45 plus, is this equal to 9 times 10, which is 90? 45 plus 45 is 90, so this tells us it's a right triangle. And this here tells us that it's an isosceles triangle. And that's it.